Good morning to all of you guys. Welcome to you all on the IMS Gate Academy platform. I think now voice is clear. All of you please do reply fast. Audio video is clear now. In the last class we have seen about the periodic and non-periodic signals. And today's class we are going to discuss about even and odd signal, real and imaginary signal, conjugate, symmetric, anti-symmetric signals. And after that we'll start the energy signal and power signal as well. Okay. So let's start, student. In the last class only we have seen that periodic, non-periodic signals, and we have seen some examples also. So we are left with 2 or 3 gate questions. After that we will discuss the even and odd signals and all. You just need to tell me which was the last question of last class. I think this is the last question of last class. So we are going to start today's class with this question. Okay, bachcho, just try to attempt this question. Try to attempt the question number 1 and tell me what is the fundamental time period of this. All of you guys just do reply. Tell me now what is the good morning, Vedai, Pragya, Purushottam. Good morning, beta. Sorry for late. Chaliye. Actually, you know that in Bangalore we have a heavy traffic. Chaliye. So now, all of you guys just do reply fast. In the first question, e to the power j omega 0 t minus j. So do you know, student, the standard form is nothing but e ki power j omega 0 t. It means the multiple of j and t is nothing but omega 0. So in the first question you can find that omega value is nothing but pi. So fundamental time period is nothing but t equal to 2 pi upon omega 0. So it will be t equal to 2 pi upon pi. So pi get cancel out. So answer will be 2. So fundamental time period is nothing but 2. How many of you are guys getting the same? Veday Singh, shabash. Now try to attempt the second one, beta. All of you guys try to attempt the second one. All of you just try to attempt second one. Yeah. I want to see your answer, guys. I'm expecting question number 2 from your side. Just confirm, guys, voice is perfectly loud and clear ना. ऐसा तो नहीं कि वॉइस स्लो आ रहा है. You should reply in live. Okay. Second question answer I am expecting. चलिए बच्चों बताइए. What is the answer for second question now? Tell me. Yes, pi by 2 pi. Okay, some students are saying 2 pi. Okay. So if I talk about the second question, student, in the question number 2, what I need to do? Because it is square na bachcho, so I need to cos square is nothing but 1 plus cos of 4. Here is 2 multipliers. So it will be 4t minus pi by, you should multiply with 2 also completely. So here also multiplying with 2. So now student, you are not looking for the phase, you are looking for only this pi, only this angle omega. So what you will get, cos square theta is nothing but 1 plus cos 2 theta upon 2. So that is why fundamental time period is nothing but t equal to 2 pi upon omega 0. So fundamental time period t is nothing but 2 pi upon 4. So it is nothing but pi by 2. Yeah. So 2 to 4 हो गया. I hope it is clear to you guys. Pi by 2. I hope it is clear to you. All of you guys just do reply fast. Shall we go for next? Pi by 2 is correct or not? Purushottam. Chali. Now tell me what about the last one, the third one. Third one I am expecting from you, beta. Third one. Purushottam. Try to solve the question number 3. All of you guys try to solve the question number 3. Infinite. It means non-periodic. Veday. It means non-periodic or what? So because this 2t nature is there, if only 2 is there, then we don't have any problem. If only 2 is there, then don't we have any problem. Why? Because the signal is independent to amplitude shifting. It means addition or subtraction of DC term does not make any changes in the fundamental time period. But here the signal 2t, that is linear in nature, it will affect the periodicity of a signal. So this third signal is a non-periodic signal. Very good. The third signal is a non-periodic signal. Shabash. Very good. Very nice. Now all of you bacha do reply fast. Shall we go for next slide? Am I expecting the next gate question from your side? Chali. Try to solve this gate question, guys. Here it is the signal sine root pi, t also in the root actually. Here t also in the root only, guys. Here t also in the root. If t is not in the root, then it will be sine root pi into t. But right now t is also in the root. Because t is already in the root, so now any operation, because t, any operation applied, root operation applied on t, so that the signal will become non-periodic. So correct answer will be option number D for Delhi. Yeah. If the signal is look like this, if the signal agar aisa hota, sine of root pi into t, then its fundamental time period will be t equal to 2 pi upon omega 0. And omega 0 is nothing but again root 2 pi. So fundamental time period is nothing but root 2 pi. Yeah. I hope it is clear to you. I hope it is clear to you. Yes or no? Fundamental time period can be in root 2, can be in pi. Because it is a continuous time signal. The ratio of T1 and T2 should not be root 2. It should not be multiple of pi. Tell me yes or no, beta Purushottam. In the last class we have seen this now. So there is a difference between these two expressions. Here t already in the root, so that is why it is make the signal non-periodic. Whether gate question IN21 is completed, beta, yes or no? So now student will discuss about the basics of even and odd signal. This will become eventually very important in the symmetrical condition of Fourier series. Fourier series satisfy which symmetrical condition, even symmetry, odd symmetry. That time this even odd concept will become important. Okay. So student, just make a heading even signal and odd signal. You all need to tell me what do you mean by even signal. All of you just do reply fast. A signal which is symmetrical about y-axis. A signal which is symmetrical. A signal which is symmetrical with respect to, which is symmetrical with respect to which axis, guys? With respect to y-axis. It means what we can say that, sir, x of t is equal to actually x of minus t. So this is symmetrical about y-axis. System is having a mirror image with respect to y-axis. System is having mirror image with respect to y-axis. With respect to y-axis. So if I talk about the examples, tell me guys, sine or cos? So of course, sir, cos will become an even signal. Because in the cos curve, you will see that the curve will be look like this, and the signal is symmetrical about the y-axis like this. So this respect to this y-axis, this signal is having symmetricity. The signal is having mirror image. So this signal is an even signal. If I talk about this square waveform pulse, this is also an even signal, sir. Why? Because the signal is symmetrical about y-axis and the signal is periodic itself. So example of a periodic even signals. Is this clear or not, beta? So how to identify mathematically? Mathematically the equation should satisfy or must satisfy xt equal to x of minus t. Xt equal to x of minus t, then the signal is even signal. So if I talk about ki my xt equation is, cos t, then tell me, is it mathematically satisfied or not? Is it mathematically satisfied or not? Tell me. So student, tell me if xt is equal to cos of t, then if I will put x of minus t, then it will become actually cos of minus t. And do you know cos minus t is nothing but cos t only. Cos minus t is nothing but cos t only. So this cos t and this cos t is equal. It means xt and x minus t is equal. It means cos function is an even signal only. So student, if I talk about the simple mathematics, if the signal is even signal, then of course we can split the limit. If the limit is minus infinity to infinity, x even part of t into dt, then of course it is equivalent to twice into 0 to infinity x even part of t into dt. I hope it is clear to you guys. So if the signal is even, you can multiply with twice and you can only take the positive half limit. You can only take the positive half limit. बोलो बच्चों बोलो, is this clear? बोलो प्यारे बच्चों, is it clear? Vedayi beta. Yes sir. Now if I talk about the odd signal, then odd signal must be symmetrical about the origin. So you can write the odd signal must be symmetrical about origin. It means you can say that ki sir, as an example, sine of t, if I will make a curve of sine t, then sine t curve should be like this. So with respect to this origin point, the signal is periodic only. So what you can say that, sir, this signal is nothing but odd signal, and it satisfies the odd signal. Mathematically, the odd signal will satisfy this equation. X minus t is nothing but minus x of t. So in mathematics, to make the signal odd, it must satisfy this equation. And graphically, it must be symmetrical with respect to origin. So if I talk about the square waveform, then square waveform also, if the square waveform is like this, then it is of course an example of odd signals. Because here the signal we have a symmetrical axis, here we have a plus a value, minus a value with respect to t. So this is also a odd signal. So if I talk the example of signum function, how many of you remember the nature of signum beta? Purushottam, Vedayi, signum function beta. So signum function is nature is this only. This is the signum function nature. This is 0, this is plus 1 and this is minus 1. This is with respect to t. So this is your x of t, guys. This is your x of t. So this is called signum signal. This is called a signum signal. Yeah. This is called a signum signal. So signum signal is even or odd. So you must say that it is symmetrical about origin. So it is odd signal. It means signum function of minus t. It means the signum function of minus t is nothing but a minus signum function of t. Yeah. Signum function of minus t is nothing but minus signum function of t. I hope this part is clear to you, bachcho. Pyare bachcho, just do reply for, is it clear? Is this crystal clear or not, beta? हाँ या ना? चलो. So now student, the question is, what about even? If the signal is neither even nor odd, so we will come to this part, but first of all we will complete this. We'll complete this table. After that we'll solve that part also. So student, the next you need to make a table. We'll again come to that part. Whatever is in the slide, we'll again come to that part. Okay. So right now you all should reply, sir, if two signals, if one signal is even, another signal is also even, if both the signals are even plus even, then what is the sum of that, even plus even? Do reply fast, beta Purushottam. If I will have a even signal cos t, if I will have a other signal t square is also even signal. So t square plus cos t will become what? Ultimately the signal will become even only, shabash. So even plus even is nothing but even. I am just writing the short notation capital E. So here capital E define even only. So even plus even is always even. What is even minus even, guys? Even minus even is also even only. Even minus even is also even only. What about even into even product? If I multiply cos t into cos t, then it will become cos square t. And cos square t is nothing but 1 plus cos 2 theta upon 2. It means the signal is again even only. So even multiply with even is also a even signal, guys. Even multiply with even will also give you even signal, guys. Like t square is an even signal, sir. And one more t ki power 4 is even signal, sir. When you will multiply, na, then t ki power 4 multiply with t square will become t ki power 6. And t ki power 6 is again a even signal, beta. Ha ya na? So it means again even upon even is also a even signal. So I think as far as first row is concerned, it is clear to you. I think as far as first row is concerned, it is clear to you. All of you guys just do reply fast. As far as first row is concerned, is it clear, beta? As far as first row is concerned, is it crystal clear? Now, if both the signals are odd, sir, then tell me, bacha, what is the odd plus odd? That is a good question. Odd plus odd. Vedehi Purushottam, odd plus odd. Odd plus odd. Are you sure? Odd plus odd, odd. Odd plus odd. Purushottam also. क्या बात है यार बच्चों. Odd plus odd will become odd, sir. Odd plus will become odd. Odd plus, because if one nature is t cube and plus t ki power 5, ultimate will become odd only. So some students are saying odd plus odd even. No. Odd plus odd is odd only. Now odd minus odd is again odd. Odd minus odd is also a odd signal. Now what about odd into even? Odd into odd. What about odd into, because both are odd, na? So what about odd into odd? Odd into odd. Odd into odd. It means sin t dot sin t. Sin t is a odd signal. Sin t is a odd signal. Sin t dot sin t is sin square t. And sin square will become 1 minus cos 2t upon 2. And 1 is a DC signal. 1 is a even signal. And cos t is a even signal. So it means odd into odd will become even signal only, sir. Odd into odd will become even signal only, sir. Bolo हाँ या ना? Odd into odd will become what, प्यारे बच्चों? Odd into odd will become even signal only, sir. I hope this part is also clear to you, प्यारे बच्चों. Is it clear? Now tell me, what is odd upon odd? What is odd upon odd? Odd upon odd. Odd upon odd. T की power 4 upon t square. अच्छा. Oh, t की power 5 upon t की power 3. हाँ. T की power 5 odd signal. T की power 3 odd signal. Ultimately will become next even also. So odd upon odd is also a even signal. Shabash. Now what about the next Purushottam beta? यहाँ पे even and odd. One is even, one is odd. When you will add both the signals, what you will get? One is even, other is odd. Then what you will get? Even plus odd. Even plus odd is what? Even plus odd is what? NENP neither. No. Nano. Even odd. Nano में sir. अरे बच्चों. Nano. शाबाश. Very good. So even and odd signal. Nano. ये तो गाना याद आ गया. Nano में. चलिए. NENO. Neither even nor odd. Why? Neither even nor odd. Because one signal is even, sir. Other signal is odd, sir. And that is the combination of even plus odd is of course a nano signal. Neither even nor odd. What about even minus odd? If even plus odd is nano, sir, then even minus odd is also a nano signal, sir. Even minus odd is also a nano signal, sir. Is it clear, beta? Nano signal? Yes, sir. What about even into odd? Product. आप भी लगता है बस गए हैं सर. नहीं. चलिए बताइए. Even dot odd. Even dot odd. Now odd will dominate. Yes or no? Odd. How, sir? How? Example दो, sir. Example बड़ा अच्छा लगता है, sir. Example बड़ा important. T square is even signal. T की power cube is odd signal. When you will multiply, you will get t की power 5, and t की power 5 is a odd signal. So odd into even is always a odd. And odd upon even क्या बनेगा? अच्छा, odd upon even पूछ रहे हो. अच्छा. t cube upon t square. t cube is odd signal, t square is even signal, ultimately you will get t ki power 1. So answer is nothing but odd. Yeah. So I hope this table is clear to you, pyare bachcho. So I hope this table is crystal clear to you. How many of you guys just do reply for this table is clear or not, beta? I am giving you proper time to write. Just complete this table, and once you complete, do reply so that we can go for the next slide. And please, student, whenever you will get the opportunity, please share your experience to your juniors, to your classmates, okay, to in your engineering college, in your canteen, whenever you will meet with your junior, just share your experience with all of them. And if it is possible, please send the link of the MS Gate Academy YouTube channel and Signals and Systems series right now going on morning 11 a.m. So they will also join us and they will also get benefited. Now student, I am going for the next. Once the signal is nano signal, if it is given that the signal is nano. Student, if the signal is even signal, then can you find out the odd component of this? If any signal is an even signal, then can you find out the odd component of that even signal? So if anybody will ask about the odd component of even signal, it is 0 only. What is the odd component of even signal? 0. What is the even component of odd signal? What is the even component of odd signal? Again 0, sir. So if the signal is a nano signal, if signal is nano, nano means neither even nor odd. Yeah. If the signal is neither even nor odd, then we have a scope to find out even component and odd component of signal. Then we have a scope to find even component and odd component of a signal. Let me take example. If this my xt signal is a nano signal, let me take, if my xt signal is a nano signal, and if xt is nano, it means it is a combination of even part of t and odd part of t. It means xt is a combination of even component of t and odd component of t. If I will replace here t with minus t, then the first term will become x minus t equal to x even component of minus t plus x odd component of minus t, like this. So when you will do this, you will actually get x minus t equal to even part of minus t is nothing but x even part of t, and odd part of minus t minus sign will become forward. So x odd part of t. Yeah. I hope this second equation is also clear to you. So I think equation number 1 and equation number 2 is now crystal clear to you. Equation number 1 and 2 now clear to you. If I am looking for only even component, then can I add equation number 1 and equation number 2, bachcho? If I will add equation number 1 and 2, I will simply get x even component of t, even twice x even component of t, because odd will get cancel out. So because if I will add the equation number 1 plus equation number 2, then I will get this expression. And the left hand side I will get this xt plus x of minus t, and x even component of t formula finally will become sir xt plus x of minus t upon 2. All of you guys, please do reply. Is this crystal clear or not, beta? Is this crystal clear or not? Just do reply fast. Just do reply fast. All of you do reply fast. All of you guys just do reply fast. Do reply fast. Yeah, x even component. Similarly, can you also find x odd component, guys? Similarly, can you also find odd component of t? If you will subtract the equation number 1 minus 2, then ultimately actually even part cancel out and you will get odd component of t similarly as a xt x of minus t upon 2. I hope this part is crystal clear to you. Yay! So even component and odd component formula we have derived just by doing a small derivation. We have now the formula of even component and of odd component, but this formula is only valid if the signal xt is a neither even nor odd signal. If xt is a nano signal, then only we have an opportunity to identify the even component and odd component which is hidden in the signal. Please do reply, प्यारे बच्चों. Shall we go for next? बोलो हाँ या ना. All of you guys just do reply fast. Bolo hi ya na. Shall we go for next? You should take your time. If you need more time for writing, you can reply in chat box without hesitation, so that I will wait for you. Otherwise, we are going for next. बोलो फिर. चलिए, now I am going for next. So even component and odd component formula is clear to you now. Yes sir, it is clear sir. It is clear sir. It is clear बच्चों. Yes. चलिए. So now student, I am coming to this part. I am coming to this part. कि sir, for this signal, or even I am just giving you example one. It is a gate question. It is a GATE 2005 question itself. It is a GATE 2005. It is a GATE 2005 question itself. GATE 2005 question. And the question is, find out even and odd component of, find out even and odd component of signal UT, where UT is a step signal. Find out even and odd component of a signal UT. Yeah, get question. Tell me guys, UT signal, you all know that, sir, UT is nothing but the step signal. So can you find out its even and odd component? Because we know that UT is nothing but 0 to T having the value +1. So this is my UT signal, pyare bachcho. Is it clear? This is my UT signal. All of you guys just do reply fast. Is it my UT signal? Bolo ha ya na. Is it my UT signal? Bolo ha ya na. Now tell me, sir, in UT signal, if I am looking for the even component, I should directly apply the formula. U even part of T is nothing but UT plus U minus T upon 2. And do you know what is UT plus U minus T? It is a property. UT plus U minus T is nothing but 1 only DC value. That is why U even part of T is nothing but 1 by 2. And if I will make a curve for the half is nothing but a DC value. So it will have a constant value half from minus infinity to infinity, and it is nothing but U even part of T with respect to T. So I hope the even component of T is UT is clear to you. Now if I am looking for the odd component, the formula itself says that the odd component of T is nothing but UT minus U of minus T upon 2. And we know that, sir, ki UT minus U minus T also one property, and that is nothing but the signum signal, sir. So signum signal upon 2 only. Signum signal upon 2 itself, meaning that it will amplitude scale by half. So if I will make a signum signal and if I will make the amplitude half, then signum signal will be look like this. Signum signal will be look like this. Yeah. So you will say that, sir, here is plus half, here is minus half, here is with respect to T. So here you will get that U odd part of T with respect to T. So U odd part of T is look like also odd signal. U even part of C also look like a even signal. Now student, you can also hence prove it. You can also prove your answer, whether your answer is correct or not. How you can prove this? If I will add my even component and odd component, I should get my original signal back. I am repeating the sentence. Whatever even component and odd component that you have calculated, if you wish to check whether it is correct or not, you can simply prove it just adding even component and odd component. When you will add even component and odd component, it should equal to question itself. It should equal to UT only. So you can say that here, sir, if I will add this even component and odd component in the positive half from 0 to infinity, what you will get, beta? From 0 to infinity, sir, positive. For positive part, plus half. For negative, for here positive part also plus half. So plus half will become plus 1 only. From minus infinity to 0, it will having plus half. From minus infinity to 0, it is having minus half. Plus half minus half will 0 compensate. So you will get the curve like this. ओ हो ओ हो बोलो बच्चों बोलो, इज इट क्लियर और नॉट? ये तो मजा आ गया सर, वापस वही बन गया यूटी, यूटी विथ रेस्पेक्ट टू टी. ऑल ऑफ यू गाइस जस्ट डू रिप्लाई, इज इट क्लियर और नॉट? इज दिस क्लियर? बोलो 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 बोलो, जोर से बोलो. चलिए. So sir, you even part of T complete, odd part of T complete is a gate question, sir. Now completed, sir. Chali. So now I am going for the next. Let me take some example graphically. Okay, graphically I am taking some examples. Let me take this example first of all, xt. Okay. So if it is my xt signal, if it is my xt signal, this is my xt signal. Okay, this is 0, 1, this is one value, and this is your x of t with respect to t. And the question is find x even component of t and x odd component of t. Find even component and odd component. So how you will get? Mathematically you will write this ki sir, x even part of t is equal to xt plus x of minus t upon 2. So what you will get? You will get, sir, this term is xt only. So what about x minus t? So if I will do time reversal only, x minus t, then x minus t will become like this. So you will get minus 1 to 0, it is having the plus 1 value with respect to t. So this is your x of t, this is your x of minus t. And if I will add, because if I will add and if I will provide the amplitude scaling with half, ultimately I will get the signal which is the amplitude having half and this triangle nature from minus 1 to plus 1 with respect to t. So it is nothing but my even component, but clear or not? Because when I will add and I should also provide the amplitude scaling with half. Whether he agree or not? Whether he agree or not? Bolo हाँ या ना? Now examiner can also ask the find out the area of even component of t. Find out the area of the x even component of t. If xt is this, find out the area of x even component of t. If xt is this, then find out the area of x even component of t. Come on. Even component of t area. What is the area? So if you want to calculate the area is nothing but half into width into height. So do you know width is nothing but 2 and height is nothing but half. So this is cancel. So area is nothing but 2 only. Area is nothing but 0.5, 1 by 2 only. Bolo bhai bolo, Purushottam Vedai bolo. Similarly, student, if anyone will ask about the odd component. Acha, odd component, odd component. If anybody will ask about the odd component, अच्छा odd पूछ रहे हो? हाँ odd पूछ रहे हो, odd component of t, odd component. Then you should take xt minus x minus t. If I will provide here amplitude reversal beta, ये signal amplitude reversal मतलब it will having a mirror image with respect to x axis, like this. So you will get a curve like this. And here also like this. यहाँ तो ऐसा ही है. So it will be minus 1, 2, plus 1, and this is my odd signal. And if anybody will ask about the odd signal, then the advantage is what, my dear student, for the odd signal, from the odd signal minus infinity to infinity, if anybody will ask about that odd component of integral, that is always 0. Odd signal area is always equal to 0. Bolo हाँ या ना, agree or not? Because this area, negative area, going to be compensated by this positive area. Yeah. But as far as the amplitude is concerned, it will be half only because we have amplitude scaling with half. हाँ या ना? And here also you guys can prove that, sir, if x even part of t and odd part of t, if I will add these two signal, this one first signal, second signal, if I will add these two signal, then this part, this left hand side part going to be compensate and this part going to be doubled. So half and half will become 1 and it will become original signal back xt. But it is clear or not? I hope it is clear. Do reply, pyare bachcho. Is it clear or not? Is it clear? Oh ho. Is it clear? अरे सर मजा आ गया. चलिए. Now student, next part. Okay. This is also a similar type of example. So I am just explaining here only. if this is my signal ft, if my signal here it is given that my ft signal is this and f minus t signal is this, it is given, f minus t is given and ft is given, and asking for its even component. Come on guys, so what you will get? So to find the even component we have to add it, to find the even component we have to add it. बोलो क्या बोलते? To find the even component we have to add it. So when we'll add now this one and this nature will add, so here you will get a temple shape like this, like this, like this. ये even component. Even component बोलो हाँ या ना ये. Similarly, odd component nature is this only. Why? Because this time what you need to do? To find the odd component, you should do actually ft minus f minus t. It means this amplitude scaling actually, amplitude reversal here. And after that when you will add, you will actually get this odd component of t. And we know that if I will add even component or odd component, I will get my original signal back ft. So that is why it's written that it's work. Yeah. And if I will ft and f minus t, if I will subtract, this is odd component. So odd component, it means you are not adding, you are subtracting. If you will add, you will get the even component. If you will add, you will get the even component actually. Bolo hai na? Here you are subtracting, here we are subtracting. So what we are doing actually to generate this, actually we need to do this, sir. ft, I am writing here only, so that is no confusion. Yeah. ft minus f of minus t, ft minus f of minus t. Yeah. All of you do reply fast. Shall we go for next? It is just like similar. Is it clear or not, beta? I think it is clear to you. So I think as far as even signal is concerned, odd signal is concerned, symmetricity is concerned, the concept is clear for even and odd. Yes. Similarly, here also you can check. Sir, if this signal is ft, and this is your ft part, f minus t part, if you will add this, then you will get its even component. This is twice of even component. This is twice of even component. If you will divide with 2, then it will become actually 1 and it will become half. If you are looking for only even component, then only even component, then you have to provide scaling with half. Yes or no? Chaliye. So next student, if the question is coming like this question already we have done. Find even and odd component of ut. That question is already we have completed. Already we have completed, sir. No problem. Now one more thing, guys. Here is one question. Can you please identify the even and odd component from the xt? If you are directly able to identify, then it is good. If you are not able to identify, then you can directly use the formula. X even part of t is nothing but xt plus x minus t upon 2. xt plus x minus t upon 2. Yeah. All of you guys just do reply. Shall we go for next? बोलो बोलो बोलो. So if I talk about the first component, sir, in the first question, the x even part of t is nothing but, in the first question, x even part of t is nothing but, sir, 1 is even signal, t square is also even nature, and cos of t is also even nature. So x even component of t is nothing but 1 plus t square plus cos t. Similarly, if I talk about the odd signal, then odd signal will become what? Sir, only one signal is odd nature, that is 2t cube. So in the question number 1, it is a even component, it is a odd component. That's it. So I think in the question number 1, it is very easy to identify the even and odd component. I hope it is clear to you, pyare bachcho. I hope it is clear to you. All of you guys just do reply fast. Shall we go for next? बोलो भाई. टी क्यूब, वेरी गुड. टी क्यूब है ये, टी क्यूब है ये. टी स्क्वायर किसने लिखा बच्चों? टी क्यूब है ना ये तो. अरे ये 2t क्यूब था यार, ये t स्क्वायर पता नहीं किसने लिख दिया, 2t क्यूब था। ऊपर जो है वही तो आएगा, नीचे यहाँ है वही आएगा सर, शाबाश। What about the second question, guys? Second question. In second question, what about the even component? X even component, oh, cos cube t, cos nature is an even signal, cos t. And but this is the only even component. Because sin t upon sin t is odd upon even is nothing but odd only. So in second question, the odd component of signal is nothing but 2t की power 5 plus, बोलो sin t upon, बोलो sin t upon t square. ये. So even component and odd component, it is easy to identify from the equation. Oh. हाँ, जल्दी बोलो बच्चों. Shall we go for next? हंसते रहे, मुस्कुराते रहे, पढ़ते रहे, अपने एक्सपीरियंस को कमेंट बॉक्स में लिखते रहे. डू रिप्लाई फास्ट. Shall we go for next pair बच्चों? NOW, बोलो NOW. चलिए. So now if I talk about the real and imaginary signal, how to identify real and imaginary signal बच्चों? So if I talk about a complex signal, then complex signal will become a real part also and imaginary part also. So if I talk about my signal xt is nothing but x real part of t into jx imaginary part of t. If I am writing my signal like this, and if I am looking for the real part, then I can take the conjugate here. If I will take the conjugate part, then I will get here what, guys? Tell me. In the conjugate, you know that sign will change only. So x real part of t, and here it will get minus ka j x imaginary part of t. Bolo हाँ या ना? So from the equation number 1, equation number 2, real imaginary, it is very easy to identify. If I will add equation number 1 plus 2, then the left hand side only I will get this part is sir xt plus x conjugate of t, and is equal to twice of x real part of t. That is why you can also say that कि sir x real part of t is equal to what? So x real part of t is equal to xt plus x conjugate of t upon 2. All of you guys just do reply fast. Is it crystal clear to you, beta? Beta. X real part of t is nothing but xt plus x conjugate of t upon 2. Oh. Is it clear? X real part of t. बोलो ना. Similarly, if you will looking for the imaginary part of t, then imaginary part of t you must say that sir it is nothing but xt minus x conjugate upon 2. So that will give you imaginary part in terms of j. So I think to identify the real and imaginary part, it is quite easy. You can easily identify the imaginary and real part. So if I will mix the two concept, of complex signal, है ना, conjugate signal and the even odd signal, if I will mix these two concepts, then we will generate one more condition that is known as conjugate symmetric signal, है ना. So if it is clear, then we are going for next. It is quite easy actually, real and imaginary. बोलो वैदेही and पुरुषोत्तम, बोलो बेटा, noted down or not? I hope you already note down. I hope you already noted in your notes. Yes. बोलो जोर से बोलो. Shall we go for next or not? जल्दी बोलना पड़ेगा आपको. Yes sir. चलिए. So now student tell me कि sir complex signal की बात हुआ. Now next you are saying about conjugate symmetric signal. Next I am talking about conjugate symmetric signal. Conjugate symmetric signals. अच्छा हाँ. And next I am talking about conjugate symmetric signal. So a signal is said to be conjugate symmetric. A signal is said to be conjugate symmetric if it satisfies xt equal to x conjugate of minus t. It means you are saying that कि sir, if I will remove the star, then it will even signal. Oh, yeah. हाँ या ना. If I will remove the star, then it will even signal. And if I will remove minus t, then xt equal to x conjugate of t, it means real signal. It means real signal. Oh ho, because real signal conjugate is same. Oh ho, मजा आ गया sir. Yes or no? That is why I told you combination. Or a signal is said to be conjugate symmetric, either it satisfied this or it satisfies this. X conjugate of t is equal to x of minus t. This is also true. So if any one, both the equations are same. If a equation satisfies this, then this automatically satisfies. So this is my conjugate symmetrical condition. This is the conjugate symmetric condition. This is known as conjugate symmetric condition. If a signal satisfies conjugate symmetric signal, then what it will be? Let's see. Let's see. So now student, let me take one more thing. Let my xt signal is nothing but a at plus jbt. At plus jbt. So now what is my x conjugate of t? So x conjugate of t will become, sir, at minus jbt. At minus jbt. It means what? X conjugate of minus t. I am replacing t with minus t. So it will become what? It will become a of minus t minus j of b of minus t. Yeah. Is it clear? Now student, to make the signal conjugate symmetric, it must satisfy this condition, xt equal to x conjugate of minus t. बोलो क्या बोलते हो? xt equal to x conjugate of minus t. It means you can say that कि sir at should be equal to what? To satisfy this condition, at should equal to a minus t. at should equal to a minus t. बोलो क्या बोलते हो? at should equal to a minus t. And bt should equal to minus b of minus t. Is it crystal clear or not, beta? So it means it is an even, it is an odd condition. I hope it is clear to you guys. It means to make the signal conjugate symmetric, to satisfy the conjugate symmetric condition, real part of signal must be even. Real part of signal must be even, because here real part is 80 na, and imaginary part is. And imaginary part of signal is what, guys? Imaginary part of signal will become odd. All of you guys do reply, is it clear or not? So this is also an important note. How to identify the conjugate symmetric and conjugate symmetric signal, yes or no? So this is my conjugate symmetric condition. This is my conjugate symmetric condition. This is the condition of conjugate symmetric. Conjugate symmetric. Now, what is conjugate antisymmetric condition? So if the signal xt satisfies this condition, xt equal to minus x conjugate of minus t, or x conjugate of t is equal to minus x of minus t. Yeah. If signal satisfies these two equations, then we'll say that the signal is conjugate antisymmetric. Conjugate antisymmetric. And you will say that conjugate symmetric condition, if I will remove the star mark, it will become even signal condition. And in conjugate antisymmetric part, if I will remove the star mark, it will give me the odd signal condition. It will give me the odd signal condition. बोलो हाँ या ना? बोलो बच्चों, बोलो yes or no? Yes sir, बिल्कुल सर, बिल्कुल. So now xt and x conjugate of t is clear. If I am looking for how to find out, just like even component, odd component, if I am looking for the formula of x conjugate part of t, conjugate symmetric part of t, then it will become xt plus x conjugate of minus t upon 2. I am telling you here, if you will remove the star, it will become even signal. And if you will add star, it will give you conjugate symmetric signal. If I talk about conjugate antisymmetric signal, XCS, conjugate antisymmetric signal, then the formula will become actually xt minus x conjugate of minus t upon 2. So this is my x conjugate antisymmetric part of t. And this is my conjugate symmetric part. This is my conjugate antisymmetric part. बोलो बच्चों क्या बोलते हैं? Is it clear? So x conjugate xt plus x conjugate of minus t upon 2, xt minus x conjugate of minus t upon 2, conjugate antisymmetric, conjugate symmetric. Only one time one gate question has been asked, that is for I think 98 or in near 2000, that is in discrete time domain. Discrete time domain. Only here t replaced with n. Then only one question has been asked from the conjugate symmetric antisymmetric in the last 30 years. I hope till here everything is clear. Yes. So guys, as far as thumbnail is concerned for today's session, this is the only given, even, odd, real, imaginary and conjugate conjugate antisymmetric. From the next class, we are going to start in the thumbnail itself, which says energy and power signal. So we'll have a number of lectures for energy and power, because we'll discuss very detailed and we'll have a many examples and all the gate questions that has been asked till now in the last 30 years. जितने भी क्वेश्चंस आए हैं एनर्जी पावर के, सारे ही करेंगे क्लास में, एक भी नहीं छोड़ेंगे, एक भी नहीं छोड़ेंगे. ओके, एंड विल सॉल्व द इंजीनियरिंग सर्विसेज क्वेश्चंस आल्सो, विल सॉल्व द गुड एग्जांपल्स आल्सो, concept also. So if you have a positive intent to learn something, you guys can attend the daily live classes at morning 11 a.m. And this is my suggestion. I will feel very happy if more number of students will attend in a live, so that the actual purpose of the session will solve. And I will also have enough motivation, because all the live students will be there. You will also have a healthy competition. However, the videos are available for the recording, but if you will attend in live manner, it will be great. Because the many students are requesting me, they are messaging me on social media. They are saying that, sir, please signals and system, start signal and system. That is why I have started signal system. In going forward in the coming time, I will also start the control system. But only and only if signal and system response is amazing. Okay, प्यारे बच्चों, चलिए. And those who are looking for the comprehensive, detailed preparation for the GATE exam, GATE 24-25, you can contact to our student advisory team. The phone number is given in the below red strip. You can directly contact them. Whatever questions coming in your mind, you should write all your small questions also. Whatever question is coming in your mind, you can write in white paper and you can ask without hesitation. They will guide you. And once you will join the IMS GATE Academy platform for your GATE preparation, you will have, you can make sure that, because you are preparing under my guidance. Okay, so at the IMS GATE Academy, if you wish to prepare for GATE 24-25, if you wish to prepare under the guidance of Ankur sir, then you must join the IMS GATE Academy. And if you are in the nearby area, you can also visit our center. Offline center is in Jayanagar, Bangalore, 3rd block, and online classes are available for across the India, all centers. Okay, every day evening we are having the online classes 6 to 9:30. And in this comprehensive course, student, you will get more than 750 lectures, live classes. After that, you will get 26 to 30 hard copy of books that IMS GATE Academy will dispatch at your place. जो भी आपका एड्रेस है, वहाँ पे हम कोरियर से आपको 26 से लेके 30 बुक्स भेजेंगे. After that, you will get 130 plus test series. You will get 84 chapter test, 84 plus chapter test. You will get 12 subject test, basic level. You will also get advanced level subject test. You will also get multiple subject test and the full length mock test. Okay, and the mock test with video solution also. So student, and of course the one more basic, that is the most USP of IMS GATE Academy that you will never find anywhere. That is, my dear student, mentorship session, my plan session, 1-to-1 mentoring. So क्लास में ऐसा नहीं कि टीचर ने पढ़ाया फिर चले गए, फिर नेक्स्ट सब्जेक्ट आया, फिर नेक्स्ट टीचर पढ़ा रहा है. You have an opportunity to book a my plan session where you can book the Google meeting slot with your mentors, where mentor and you only will be talk for the 30 minutes. आप दोनों आपस में 30 मिनट तक बात करोगे. जो भी आपकी पर्सनल वीकनेस है, आपको लगता है कि पर्सनल स्ट्रेंथ है, आपको डिस्कशन का पार्ट है. It is all about the strategical discussion about your preparation. As far as doubt solving is concerned, we are having a dedicated doubt solving platform where you can easily upload the doubt just like WhatsApp. You can take a snapshot, you can attach there, and you will get the solution from the mentors. So all my mentor team, I am already trained them. So all mechanical, civil, all the EC, electrical, IN, all the computer science mentors are here, very energetic, and they are having daily live classes, guys. So you can definitely visit our website also, IMS Academy. And if you have any doubt, you can directly contact to the given number on that slip. Okay, bachcho? And zero fee link also given in the description. Zero fee link also given in description. You can just have access of IMS Academy features by paying 0 rupees. Okay, no need to pay. Just enroll yourself and you will get. Chali. Okay, beta Purushottam as well as Vedai. That's all for today's class. We'll meet beta tomorrow morning. Tomorrow we don't have class actually. Tomorrow is my birthday. So on my birthday, I will be on leave actually tomorrow. So tomorrow we don't have any class. Okay. Day after tomorrow we'll meet. Okay, Vedai Purushottam. Tomorrow I will spend some time with my daughter and with my son. Okay. चलिए, so कल का आपका छुट्टी है. Tomorrow we don't have YouTube class, but we'll definitely meet day after tomorrow. Okay, beta. Bye bye. Bye bye, Purushottam. Vedai. Okay, प्यारे बच्चों. So that's all from today's class. Bye bye, बच्चों. Happy birthday in advance, sir. Thank you, beta Purushottam. Thank you for your lovely wish. Thank you.